start that recording. Okay, so it is officially 2:05, so everyone should be here. Let's hope that's the case, and we're just going to kind of run through, and we're not going to do, later on you'll see some references in my lecture notes about wanting to, of course, have everybody introduce themselves. I see some people have already started introducing themselves on Discord, which is really cool, and we're going to reserve some of the introductions for when we're really in person, because I think it'll make a little more sense. So on the 24th, when we're actually all together, we will do that. And you guys, you probably have all, a lot of you have met one another before, because you probably have taken Intro to Game Design, or AIM, or any of the number of other different GSAS courses that you kind of start off with. So you may all know who one another are. But I don't have that luxury at this point. But you, chances are, it will be important that I'm going to want to know all about you folk, because not only will I have you this semester, but chances are, fingers crossed, that you'll wind up in my Game Dev 1 class next semester. Certainly GSAS majors will. That tends to be a pretty big class. So that'll be next fall. So we're one big happy family here. Now let's kind of run through here as quickly as we can. Ibrahim, are you here? I think I saw you. So, okay. Gavin. Tyler. Nicholas. Nicholas? No Nicholas? No obvious Nicholas at this point. All right. Ah, okay. Lakota. Lakota? Is another mic not working? Yes, I could see that you're there, but your mic does not seem working. Bargav. Did I totally mutilate that, or is that, how do you pronounce your first name? Oh, okay, I wasn't too far off. Bargav. Okay, we'll try. I'll work on that one though. Liam. Liam. Oh, I see a Liam, but I don't see his mic, or Liam's mic coming on and off there. All right, Liam, you're with us. At least you're tuned in. Oh, sure. Okay, I'll take everyone's word for it. Joe. Okay, Daniel. All right, Brendan. Joao. Joao? How do you pronounce your name? Jiro. Okay. Okay. Antonio. Kevin. Jay. Oh. That's interesting. It could be that, let me make sure everyone's got the proper roles first off. Oh, yeah. Let's see if I can change that. They had changed it because of the whole pandemic, and now I think maybe they changed it back because it was at over 25 before. Yikes. Invites, permissions. Oh, user limit. It says no limit. I'm going to set it to 30. Save changes. Limits users with the move members permission. Ignore this limit and can move other users into this channel. So let's see. Oh, so when I have my camera or anyone has their camera? That's the question. Okay, so that took hold. All right. Okay, let's see if we can get, maybe it needed me to like go out and back in again. Interesting. All right, I will leave that off. As much as I like to leave that on, I guess we need to do that. So if someone can go ahead and tell Rebecca to, oh, okay, Rebecca's here. Hi, Rebecca. All right. Well, this is a slight damper on my stuff. Well, you know what? There are ways I can sneak, like, because I can always do this, right? But that's cheating. I'll have to work that out for next time. So we'll cheat the system somehow, and we'll get that to work. But for now, this will do. The important part is that you can see my screen. Not so important that you see me. The recording will have me in it if you really are that interested. Mostly it'll be me just gesticulating, moving my hands around, and all that kind of stuff. It's not all that important anyway. You'll get used to that. It's not that exciting. Okay, so where were we? Timothy. Okay, we're working our way down attendance here again. So we had Timothy, Sarvesh, Amanda. Amanda? Toby. Did I lose everybody? Toby? Okay. Amanda, are you here? Okay. Chung Wei. Nick. Boyun. Bisheng. Okay. Amanda? No Amanda. Well, that's pretty good. And I think there's probably a few people, if you're not on the attendance list, shoot me a direct message just in case so that I know and we can, yes. Oh, that's right. Okay. Yeah, she wound up, yes, you are correct. All right. Sometimes it's keeping track of all these things easier said than done. Okay, so as you can tell, I don't know if I'm a big fan of LMS, but I'm certainly a big user of LMS. It has its ups and downs. It's certainly not the greatest system in the world, but it is a nice central repository where we can see stuff, and I will use it for posting grades, making announcements. There'll always be, as part of your any sort of project or submission, whether it's a design document or even just to let me know that, yes, you've submitted a project that is now available on Itch or on Perforce or on the Unity team servers. Even if it's an external submission, there'll always be some sort of component of that on LMS, right? Because that's where the grades all kind of happen, and I'm going to, have the feedback to you in terms of, the project and what your grades are and so on. So you're always going to want to check that. And also on um, LMS will be, like in here, we have now general resources and lecture notes. So there is the syllabus and feature points and day one introductions. Uh, Rather than have my lecture notes permanently embedded here in the LMS, though, is I have a live link to a Google document. A big fan of Google Slides, Google Sheets, Google Docs, and so on, all my presentations, so that I can kind of keep things up to date and live and current. And if there's any changes, I don't have to worry. And especially because I have sometimes multiple sessions of the same class. So everything tends to be a live document in there. So I'm going to encourage you to refer back to things on there, and as things, as we add feature points, or we add project bonus points, things like that, they'll show up in here. So you will be, chances are, revisiting LMS. You're all familiar with LMS at this point, I'm sure. Anyway, so let's look at the syllabus. I'm going to start kind of in the opposite order a little bit than what I did this morning, just in the interest of kind of going through things. The one issue today is I have a doctor's appointment at 3:30, so we have to end a little bit early. And I'm going to leave you with that time basically to set up Unity on your computer. So you can use that time to download Unity, which is a reasonable download, and install it and kind of kick things off, and you can use that. Don't worry, not going to really miss too much with that 20-minute early break, and I'll make it up to you somehow. All right, so course information. Yes, this is Intro to Game Programming. I'm sure you're all well aware of that by now. And it is the 2 to 350 section. It is not fall of 2021. My apologies there. See, there we go. It's a good thing this is a live document. I can just change it as we go. All right, boom, much better. We are going to be meeting in Sage 2510 when things actually start to happen, so that'll be good. You're probably all pretty familiar with that room as well. I'll save my introductions, my cool introductions, to my actual presentation. But anyway, the important things to note in here is that there are, the official breakdown of our class projects and the grade system, how that all works. We'll talk more about the 4 projects and their associated feature points in there. There's some general guidelines on the submission of assignments. There are potentially points taken off for things not submitted correctly or not commented correctly, because that's largely how we're going to make sure how things get done. That'll be more obvious as well. Some policies here about late assignments, right? There is a penalty for turning in things late if they are unexcused. If you have, for some reason, valid excuse, you have, an illness of your own in the family, an important visit from somebody, some other class has something really, really critical going on, let me know. I'm pretty flexible, as certainly Rebecca will, attest, having taken a bunch of my classes before. I'm pretty flexible when it comes to assignments like that. I'm not one to say, well, you were late, then obviously you don't know the material. But out of professionalism, we have to keep track of that sort of thing. A lot of boilerplate stuff in here. Where did my attendance policy go? There is an attendance policy in here, and the important thing is, you'll notice there is an official attendance policy, which is a little bit different in the event that we are online, in terms of being able to follow up with recorded lectures and so on. The intention is not that there would not be every lecture will not be recorded. This is a live class. This is going to be an in-person class. I expect to see people in class. We have a TA who will be in class, not here today, unfortunately. We have a mentor who will be in class that you'll be able to interact with, get lots of information from, get questions answered, and all that. So we're providing you lots of these resources, but it's important for you to be there in class, and it tends to work to people's advantage. I've found in the past, basically, the people who have sort of been lax about attending have been the ones who have run into issues. So I'm just going to go ahead up front and say, let's be good about that, and let's generally plan on having a fairly vigilant attendance policy. So officially, there are 2 unexcused absences. So for whatever reason, if you just don't want to say you just vanished for one day, all right, things happen. But if you have excused absences, they don't count against this. So it's always in your interest, if you are okay with sharing why you're going to be out and it seems like a reasonably valid thing, then let me know about it and we'll work it out. More than 2 unexcused absences may or can cause a drop in your final grade by 5 points. So 100 goes 95, et cetera, et cetera, et cetera, for each unexcused absence overall. Am I going to be taking attendance every class? Well, maybe not. You want to be there, definitely want to be there on the classes where I am taking attendance, if not all the time. Having a TA and having a mentor in class also make that a little bit easier to keep track of everybody. But we also want to be interacting with one another. This isn't really, the class is not meant to be boring or a burden or terrible. Hopefully it's engaging and you're interested enough. Believe me, a lot of people would like to take this class. So I hope that everyone is here who is, signed up for the class is, here for the duration. I have to say no to a lot of people who want to take this class every semester due to just, overall limitations. I'm sure some of you who I did the dance with in terms of, trying to get you in to the section, we did go a little bit over. Obviously, we went past 25 or 24. Normally, this class is restricted to 19. So I expect everyone who's here to be attentive and to be there and to be submitting stuff and being interactive and interacting with one another as well. That's to your best interest in the long run, of course, because if you are certainly in the GSAS program or you're taking any of the upper level GSAS classes, you're going to be working in teams, you're working in group projects and so on. So it's going to be important that you know your fellow students, you establish reputations, hopefully good ones, professional ones, working relationships and so on. Right. So that's why attendance is important. Right. There's a big portion of things to be there in person. Lots of other kind of standard RPI boilerplate course policies. Don't copy. Don't do things word for word. Have integrity and so on. You can read those at your own leisure. Some rules on appropriate programming practices. It is okay to kind of work together to help one another out. What's not appropriate is copying word for word or copying pasting stuff you don't understand, right? So if you have study sessions or work together on different things and you can kind of, okay, let's take a look at how these things work or analyze certain things, or did anyone, does somebody understand the thing he talked about in class better than I did, whatever. That's cool to talk about that sort of thing and interact with one another. What's not cool is strictly cutting and pasting stuff and not knowing what it is. I reserve the right to at any point ask you how you came to that solution, how you implemented that feature, and if you say, well, then, you won't get points for that, right? So I'm going to be very interested to see, okay, how did you come to that solution? How did you decide to implement this? What were your thoughts on? Could you have done it a different way? And so on and so on, okay? So that can happen. Otherwise, fairly boilerplate stuff in here, right? Things like you can't split a problem's workload. You can't say, okay, you do one half, I'll do the other half, and we'll submit each our own. Can't do that sort of thing. Same or similar work without permission, so on and so on. Appropriate language, very, we're informal but professional, so that's important here as well. We like to address everyone in the ways that they feel appropriate and represented and is representative of themselves. So let people know. Sometimes people don't know, and not out of disrespect or unkindness or anything like that. Sometimes people just don't know how people want to be addressed or treated and so on. But we always default to professional, courteous, and so on. But if there's additional information we need, feel free to speak up. Feel free to correct someone. Do it in a way that is compassionate and that is understanding, and we'll all be good citizens and life will be pretty good. I go by Professor Amorous, Dr. Amorous. For starting out, once you get into my upper level classes, maybe we'll get even a little bit less formal than that. Do go by kind of traditional he, him, and so on, or they, them, if you want to be more formal about it. I've studied a number of languages, and I actually in some ways prefer they, them, because it does kind of take everything out of the equation, but I'm okay with he and him as well. Okay, so the other two most important things there in the syllabus, want to make sure that you know so that you can refer back to them, is that there is a schedule in here with important dates, including when your design documents, and design documents in this class is fairly informal. The design documents are just as much for you as they are for me, because they're going to be the roadmap. You're going to be basically saying, okay, here's my intentions with regards to this project. Here's what I'm setting out to do. And it's going to give you a roadmap to completing the project, right? So generally, the point values on design documents aren't huge. Usually they're around 3 points or so, and they can be fairly informal. They're going to have to be more than just a regurgitation of the project requirements. You can't just say, I'm going to create a project that meets all the criteria. That you can't do. Some thought has to go into it, but you'll see that there are design documents due, and they don't have to be super formal, super long. They can be as, they can include hand-drawn sketches if you like. They can be, largely text, just a text file. One page of text is often more than enough, especially like the first and second projects. You don't have to go overboard. Again, it's about, just as much for you as it is for me. You want to get your ideas across and your thought process across, but also be setting yourselves up for success in executing your plan. So as much a plan as it is a design. And then there are, of course, the project due dates, right on here. They are due the midnight of that day. So if it says Tuesday, February 1st, it's due midnight Tuesday, February 1st after class. This way it gives us some time in there, some office hours and some in-class time for studio and so on to kind of wrap things up. We do miss a class due to President's Day on the 22nd. We'll refer back to this just in case I goofed and got RPI's or misinterpreted RPI's calendar. But my understanding is that we do miss that one class in February, as well as some spring break classes, obviously, because spring break, right? The final project is due the last day of class. Oh, I'm sorry, I forgot to fix this. For some reason, the last week of classes isn't shown. There are going to be optional presentations on your final projects, or really an overall demonstration of your project, if you like. It's an optional thing. It's not compulsory, but we're going to leave it open so you can kind of we'll do like a sort of a mini game fest to kind of wrap up. If you want to show your stuff to your classmates, but not do something maybe as formal as showing a game fest in the spring. We'll do presentations, and there'll be some points involved in that. Right. So if you want to see the topics, they're all there. These are all subject to change, though. If we see that people had lots of questions on a certain topic, or sometimes Unity will add new features, or something will happen in the field, and life will change, and we'll kind of move things around as necessary. But it gives you a pretty good roadmap of the important stuff that's going on. All right. And then, last but not least, or perhaps one of the most important features of the syllabus here, is that there's something called the feature point, the experience point feature values, baseline. There are points for certain features. We'll talk in the lecture, in the actual lecture notes, about what they mean, but it's here for you to refer to. And you'll see that there are lots and lots of potential features for you to implement, and they can be implemented basically in any of your projects, and you can get points for them, right? So we'll talk about that in the real lecture. Any questions so far? So far, so good. I do tend to talk. I will try to keep things moving along kind of on the quick side. So jump right in, interrupt me. You have something that you need to say. Don't worry about interrupting. It's kind of tough if you want to turn. Well, I guess we can't turn cameras on and wave our hands and so on until I figure out some way to make that work. But do turn your microphone on, ask me a question if need be. All right. Otherwise, we'll jump on over. Let's see. There is no final. There are no tests. This is all project based, right? So it's just the 4 projects, which include their design, their small design documents, and then it's all about the feature points. This is a practical course, or a studio course, right? No midterm, no final in here. The proof is you doing stuff. Okay. All right. And let's jump in here. Good. I can see some people are already tuned in, and we'll take it from there. We'll see how far I can get. I forget how many slides do I have here. Plenty of slides. Okay, so welcome to Intro to Game Programming, GSAS 2540. If you need to check, that's where we really are. Hopefully we will be in person starting on the 24th. That's the plan, and today is going to be all about sort of what I think of when I hear the term game programming, what I expect from you, what you can expect is going to be coming down the road, how we're going to get there, a little general background. You can get my perspective on things, my perspective as to why I think this is a cool course, not just because I'm teaching it, but because the topics that we'll cover. Who should be taking this class? I'd love to start off on that. Now, obviously, the way that I've designed the class, that I've been teaching the class, I've geared it towards the following. Who is this class for? It's anyone wanting or needing to understand firsthand what it means to program games, and not just what it means, but to get their hands dirty, to get those wonderful game bits under your fingernails, in terms of really getting a practical feel for it. You're not necessarily going to design masterpieces. Your goal may not be to be a programmer. Okay, to be someone CS devoted and really be coding games. You may be an artist. You may be a writer, you may be a producer, you may be any number of different other things, or you might just be interested in games as a general topic. But it is all about kind of getting a feeling, getting understanding, and getting a background so that you know what goes into programming a game. There's no hard requirement on experience, on programming experience from this class. Now, I do think that my assumption at this point is that most of the people in the class have taken CS1 or the equivalent. Some people have taken computers for engineers or for arts or for, there's a bunch of different topics on there. But by second semester, usually you've taken that course or you're taking it concurrently. Is anyone not in that camp? If you're not, don't worry. You don't have to, never have to shout out something that you don't feel comfortable shouting out. You can just message me on the side, but I'll just let you know what my assumptions are. Okay, so experience is desired, but not necessarily required. We're going to be starting from the ground up. From today, you're going to be installing your software for the first time, assuming you're, of course, you know how to use your computer, you know how to use Windows, you know how to use the Mac, whatever it is the computer you're using. So we'll be doing a certain amount of tech support along the way to get you kick-started and so on, but basic computer skills are the big assumption that we have here. There's always a wide range of backgrounds in this class, and we'll use that as much as we can to our advantage, because quite honestly, I've run into lots and lots of people who have thought they were experts, but missed something along the way. They didn't realize, hey, wow, I never knew it did that. I never knew it had that feature. I never knew I could do something in that way, because they kind of quickly developed their own methods, or maybe they learned from someone who had their own agendas or their own biases. And having a broad range of people in the class is really cool, because we can always question anything. Why does it work that way? Why do we do things that way? Couldn't we come up with a better way of doing it? That's cool, right? So we use that to our advantage. There are minimum requirements, but no maximums. What that means is your games can certainly go beyond the minimum requirements, but I expect that you do not ignore those minimum requirements, right? If I say, hey, I want to have, one of the features in this should be a directional pad that uses the Unity GUI and canvas with buttons on the screen and buttons that are clicked that attach to something. You can't substitute in. You shouldn't substitute in key presses, for example, because, otherwise, how do I know that you got the more advanced feature, the more complete official quote unquote version, and why we do things in that way, right? So you want to be careful to always be covering those basics, the things that I'm stressing, but feel free to go above and beyond. If you want to dynamically attach methods to screen objects and do all sorts of things, there's lots and lots of room for going way above and beyond. Unity, Unreal, any game engine, any game system, any programming language, it's impossible to cover it in one course, and you may have interests and depths that you want to go into that are above and beyond the class, and we'll try to give you the room to do that. Okay, but remember that you want to demonstrate mastery of the basics before you go jumping into the deep end of the pool and losing the rest of us along the way, right? So be careful about that, but there's plenty of room to go on and express yourself above and beyond. All right, so pardon my puns. Yes, there's a few of those. I am a dad. I have two, and now they're grown folks who are RPI grads. So if you have any questions on what it's like to get out of RPI, I can help you with that as well. So all kinds of background when it comes to RPI. All right. So yeah, that was my way of pardoning myself for giving dad puns because it just comes with the territory. So this course, is it basically how to use Unity? Is this, how to program in Unity? Yes, to some degree, because we want to have some practical basis, some tool set that we use that, yes, it's what we're going to be using. So we use Unity for that, but we want it to be more general. We want it to be applicable to other programming languages, other engines, and so on. So this isn't just intro to Unity. It's not just programming in Unity. It's above and beyond that. We want to learn concepts that apply across just about any game programming you might do, even if you're writing your own game engine from scratch, or writing something in Pygame, or writing something in JavaScript, or writing something in C, C++, Go, whatever language you want, right? So should above and beyond just Unity, certainly. We do love Unity tutorials and all that kind of stuff. You can just find that stuff on YouTube, right? There's lots and lots of Unity specific stuff out there. Sometimes we'll need it. Sometimes you'll want to find it. Go ahead, knock yourself out. Use stuff you can find other resources on. Be a little bit careful to make sure that it doesn't wind up looking like, oh yeah, I didn't know what was going on, so I just grabbed a Unity tutorial and cut and paste that in there. That's even worse if you wind up implementing something in some way that I didn't teach and you can't explain. Then that's a problem, right? That's kind of a slippery slope. So be careful. There's lots of great resources out there for you to use, and I encourage that, but make sure you understand how they work and how they relate to the stuff we're talking about in class as well, because it's not just, get the job done, right? It's how to think about programming and scripting. You might want to tack on some other titles for the class, intro to game architecture, perhaps, intro to game architecture programming, intro to game programming methods and patterns, so it's sort of the computer science side of things. Wow, I guess as I go through these things, I'm always thinking to myself, yeah, maybe I should have, I rebalance a lot of my lectures as I go, and somehow my personal introduction floated towards the middle, and this Unity stuff floated up front. But anyway, we'll just go with it. So why Unity? Why not Unreal or something else? Right? That's a question a lot of people ask because they've heard all this really cool stuff about the Unreal Engine and how it looks so amazing, and it's got Nanite and it's got Lumen, all these great features, and that's all well and good. But it's kind of we're faced with a choice. Unity and Unreal, they're the big AAA game engines. They're both capable of amazing things. They are both really, at the end of the day, depending on how much work you want to put in and how much depth you want to get into, they're capable of very, very similar results. But this course, since it's set up to be a programming course, it's easier, certainly from the get-go, to dive into programming from what Unity offers as opposed to what Unreal offers, right? If you want to really program in Unreal, you've got to spend a whole bunch of time in Unreal and kind of get beyond blueprints, get into C++, get into a lot more deep things, because there's a bit of a more significant barrier to entry in terms of the programming, kind of in-depth programming side of Unreal. It tends to be a visually scripted kind of, use large blocks of functionality when you're in Unreal, as opposed to starting from the basics and working your way up, which we do in Unity. Yes, so that's why that works. Okay, so we kind of dive in, start programming at this gentler pace, and C# is more forgiving than trying to go full on C++. And we can dabble in visual scripting using Unity's Visual Script as well, which has lots of great parallels to what you can do in Blueprint, but it's not quite as heavy a lift, as we say, as Unreal is. So feel free to also refer back to our previous slide about, yes, we want to focus on those concepts, right? So we can see underneath the covers, we can kind of understand underneath the covers kind of what's going on in Unity, even what's going on in its game loop, and so on and so forth. So it's an easier thing to kind of study. All right, now introductions. Whew. Now, normally I would have everybody, like I said, everybody introduce yourselves. So the one person I do, since Rebecca is here, I do want Rebecca to introduce herself. And you'll also be with us in class for the most part, right? Okay, so there are going to be chunks of class time. You'll find nearly every class will have, hopefully, depending on depending how long I blather on, some portion of studio time at the end of the class, so you can actually, kind of take whatever we talked about in class and kind of, create your own little exercises based on that, or try some stuff out, try the code out, and so on. And Rebecca and Justin, our TA, will help you out with that kind of stuff as well. So the more lively and interactive and so on we can be, the better. Okay. So feel free to put yourself some written introductions in the introductions channel over on Discord. We do use Discord a lot because it's convenient, it's popular, it's, most people who are gamers are no strangers to Discord, so it was really cool. We were kind of ahead of the curve when the pandemic hit. We shifted to online. GSAS people had no problem. We're just, we're used to Twitch and Discord and YouTube streaming, all that kind of great stuff. But anyway, okay, so me, I'll introduce myself though, because you're going to be listening to me at least for 2 weeks before we get to see each other in person. I'm Eric Amherst, PhD. What that means is basically I'm just trying to convince you that you're getting your money's worth. So you tell your parents, yes, they didn't just find some bum off the street who played video games. I've been around for a little bit of a while. Feel free to refer to me as Dr. Eric, Dr. Amherst, Professor Eric, whatever you want to do for now. And the longer we get to know each other, we'll kind of take it on from there. Amherst rhymes with glamorous. So if you need a pronunciation guide, that works out. I teach this class. I also teach Game Development 1. So that's the class that you're most likely to encounter me in. So I'll probably see you, I meant to edit this morning. You'll likely see me in the fall. I do also teach computer graphics for games, which is now the one of the official intro to to graphics programming courses here at RPI. So a lot of CS majors as well as GSAS majors take that. And we also have a game architecture course. Both of those you typically take as junior or senior kind of level courses, but I'll probably see you over in Game Dev 1 next year. My background is I did a lot of stuff in the game industry. I developed tools which mostly middleware tools, kind of add-ons, side things, plugins, system tools, third-party tools, usually working directly with a engine or a game platform or console manufacturer to provide then to their developers. So I've worked with folks like, you may have heard of Atari or Sega. I was heavily involved in the launch of the Saturn and the Dreamcast, Sony, the PlayStation 1, believe it or not, Microsoft, Apple, Adobe, Google, others, that kind of stuff. So lots of fun historical perspective. I usually don't tackle too much, but if there is interest, I can say, yeah, what was it like being there when, the Sega folks dropped the bomb about the launch being pushed back a few months and none of us being ready for it. Yes, I was actually there, and I pooped my pants when I heard that one, because then we had to rush and spend time in a hotel room cranking out all kinds of stuff. But anyway, okay. So if you need perspective on the horrors of game development, I'm here for you, which also means that I can appreciate a lot of the issues that you may run into, things like crunch time and working at the last minute and getting things to kind of do things that you never thought they would do, or sometimes when games behave in ways that, or engines behave in ways that you cannot explain. I've been there, done that, dealt with those things. So we will encounter those together and we'll get some perspective on it. My favorite types of games, usually adventure and survival horror. I'm a big Minecraft fan. I don't know why I didn't put that in there. Probably it's the most hours until I just kind of had to kind of cut myself off from Minecraft for quite a while. I like Minecraft a lot. Additionally, I play Dungeons & Dragons 5th edition, mostly on Roll20. Been playing that online, have a couple of campaigns going on there. And then all the fun games like Animal Crossing, Alien Isolation, I like that one a lot, BioShock, Intergalactic Mining, Borderlands, Zelda Breath of the Wild. Still haven't finished. So I'm working through a backlog of games. I'm also a big Lego fan, a maker. I've here at home, a couple of laser cutters and 3D printers and a workshop and chickens and a music studio, all kinds of crazy things. So I like to think I have a good breadth of things. So feel free at any point. What I'm trying to say is ask me anything. Nothing is kind of off bounds when it comes to different aspects of kind of production and creativity and so on in a lot of these things. I did work at MPAC at one point. I should put that in the slide. I worked at MPAC for quite a while. How to reach me? Normally, okay. Normally it would be in West Hall, 312A. There's kind of a corridor, a bunch of us, GSAS faculty kind of share in there. Not sure what we're going to be doing as far as in-person in-person meetings, so we'll see how that goes. But normally it would have been in 312A. You can usually find me on Discord as Eraser Mice. You can kind of figure out why I go by Eraser Mice if you're clever. I haven't been streaming on Twitch much lately, and I do have a YouTube channel which goes by LearnMax. That's usually, if I do wind up posting a lecture, it'll wind up there. Office hours normally are between the morning and afternoon session, right? So I'll either be online on Discord or in my office, so available. I do highly encourage you to contact me before just showing up in person, just in case. Sometimes my office is wherever I am, and I do have a satellite office in the CII, the Center for Industrial Innovation, the big white building next door to the DCC. There's a visualization lab there that I work in, and so often you can find me there as well. And I've got some cool Unity stuff going on there as well. Maybe at some point we'll have a field trip. And you can always get me at marie@rpi.edu. All right, use Blackboard system a lot. Already talked about a lot about that. You know where it is. It's your friend. Right? When in doubt, check LMS and make sure to go back and check out the notes on LMS, lecture notes. Try to keep them current. If I forget to post, I try to post them after the class, sometimes before class, but usually after. Occasionally I'll get busy or life will jump in the way and I won't get something posted in time. And if you are looking for something and you miss it, feel free to speak up. Always ask me. We have an optional textbook, Introduction to Game Design Programming, Prototyping and Development, specifically using Unity and C#. There's a newer version, I think a 3rd edition now. I haven't reviewed the 3rd edition yet, so I'm still keeping it optional. It's mostly if you find that you're not able to kind of keep up with your needs, just something to anchor yourself. It's a good book. I really need to check out the 2021, I think it's 2021 version or 2020 version. If it's not 2021, I would say, skip it all together and we'll just, learn all this new stuff together. 2021, it's not hugely different, Unity 2021, but it's different enough that to me, it feels like a significant, big jump up. I'm excited this semester to be jumping from 2020 to 2021. So you'll see on that. But it's a good reference, and there's lots and lots of stuff online. But if you do find yourself kind of like, on uncertain footing, you're just not quite finding your way, there are a few of the games, even the prototypes in here, like the Kaboom game, the apple picker or dropper game, that is actually kind of prototyped in this book as well. Unity platforms, hopefully we're either using Windows or the Mac in here, right? Any Mac users out there? Anybody? Okay. Well, you don't have to worry. Unity, from everything, I don't know if you have an M1 Mac. I'm excited. I still haven't gotten an M1 Mac. I'm still on Intel Macintoshes here at home. But I've only had good things, good experiences with the Mac. So it's definitely a one-for-one kind of thing. And there are Linux previews and betas out there, but I've kind of stayed away from them. I don't recommend going into that unless you're really looking for just a challenge, like an independent study or something like that, where you want to really explore the depths of, the shaky ground of Linux and Unity. Anyway, okay, so that's a little bit about the background, what's required in the class, where we are. Okay, what is game programming? After all, I'm sure you have an idea what programming is, but game programming can get a little bit odd, and sometimes there's even, you see people at higher levels who are like arguing about, well, what's important for a game programmer to be able to do? Everyone should be able to do some scripting in a game engine, right? But is scripting programming? What's the difference between scripting and programming, right? You may have heard those terms. Now, officially, when we talk about scripting, it's usually means that there's some sort of embedded programming language in a game engine that allows you to control aspects of the game engine. Right? So officially, that's sort of what scripting is known as. But the process of scripting is the same as programming. You are, using a language to basically tell a computer what to do. You come up with your own algorithms, your data, and you manipulate them in whatever scripting language you have, similar to another programming language. So all these topics, call it whatever you want, coding, scripting, programming, I don't care. To me, it's all about this process of taking some algorithm and encoding it into some notation, usually a programming language, maybe a traditional text-based one like C# or C++ or something, or it could be a visual programming language like Unity's new one or Blueprints in Unreal. But the goal is to get it into some form that then the computer understands, so that the computer can then compile it and execute it. Right? It can be running your ideas. So hopefully nobody is dreading this course because they're saying to themselves, I'm an artist, I'm a writer, I'm a musician, I don't want to have anything to do with coding. Well, scripting, and especially visual scripting and so on, have been designed, have been embedded in these engines to hopefully make your life a little bit easier. But because at the end of the day, even if you don't think you're a coder, you're going to be working with coders to realize your vision, to incorporate the product of your creativity into games, right? So you're going to want to know that lingo. You're going to want to be able to talk the talk, walk the walk, and don't let someone BS you about like, oh, we can't possibly do that. Your art looks great, but it's all there, but whatever. It's great to have common ground and understand how things work. Same thing from the programmer perspective. You want to know, okay, when someone hands you a piece of art, how does that get integrated into a game? How do you use it? How do you manage those assets within a game engine? What are the workflows and things that are involved in that, right? So there's this back and forth between getting assets into games that are created by the creative people, or going through the whole process, the programming process, according to production and so on, right? So it's important for us all to kind of be cognizant of that. And generally, people who are coming to game programming are coming to it because they have some additional ideas about, hey, they're, some kind of creative output. It's not just computing for the sake of computing. It's not just programming for the sake of programming. I mean, maybe you really enjoy that. It's your primary motivation. But, chances are, I'm betting that all of you have other interests and backgrounds that you sort of bring to the table, certain creativity that you bring to the table. That's why you want to do games as opposed to build a spreadsheet or a financial application, something like that. So it's important. And sooner or later, if you are, you have creative output, in order to make it come alive in a game, it happens because of programming some way, or scripting, or using the game engine, convincing it somehow to do what you want it to do. So it's important that we talk about it. How do we figure out, communicate with and among coders, and so on? Because there's this idea of clear definitions, okay, all I'm going to do is program, all I'm going to do is art, all I'm going to do is produce or write or design. That's not happening, especially during your academic careers, because you can tend to be working in smaller teams under shorter deadlines with, in crunch mode, with lots of other classes going on. And it's going to be important that you can count on your team to kind of fulfill whatever roles are necessary. And one of the biggest in-demand things, just because it's often the most time-consuming at the end of the day, what really establishes, does your game run well? It's the programming. So it's important, right, that you be able to kind of step up. Anyone should be able to step up to some degree and do some scripting or programming or coding of some sort, right? And the good news is that tools are designed with that in mind. A lot of game engines, they always pitch themselves as like, hey, I developed a game without writing a single line of code. Okay, you didn't go through a traditional programming process, but somehow you told the computer what to do, right? So that in our realm here kind of counts as programming as well. There will be features we implement without writing a single line of code. We'll be doing, using building blocks of things, components that are going to establish behaviors and make things work in certain ways, putting a rigid body on a game object, making it subject to gravity and making it move dynamically in the game, and so on and so forth, right? But then you might want to affect how that works, so on. So we're going to be going up and down lots of different levels. This is really the reality here. Everything is this wonderful, blurry mess of color and creativity and output and so on. And the programming side, programming is about rules and data. That sounds cut and dried. Maybe actions and objects sounds a little more dynamic in terms of being engaging, right? We have actions and we have the car that we're driving, right? The accelerator pedal that we're pressing. But there's also things like the 3D model that we're manipulating or animating, right? So there's always some kind of data, and there's some kind of rules or action that is being performed on that according to our code, right? We have code and data, or rules and data, actions and objects that we're going to be referring to throughout here, right? So it should be a piece of cake. Well, not always. I mean, Here's a chunk of code. Actually, this is not even, I think it's, where did I grab that from? I forget where I grabbed that from, but it's not even Unity code. I should find some better Unity code to substitute in there. But don't worry, it's not meant to be shock and awe. It's not going to necessarily be that way. Most of the things you're going to do in this game or in this class, if you find yourself writing lots and lots and lots of code, pages and pages of code, chances are you're doing something wrong, right? We want to write efficient code. A few statements are usually all it takes to demonstrate a point or to get something to do the right thing. So you'll be surprised to find that it's not about lots and lots and lots of coding. Sometimes it might be as you get more advanced, but the basics shouldn't be all that daunting, right? So the moment you find yourself going down that rabbit hole and heading for panic, step back, let us know, reassess, see where you're going. All right, game programming or programming is hard isn't necessarily the message here. It's something to be careful of. You get the ideas, the basic ideas of programming, but what is game programming, right? I haven't said anything about game programming yet. Rules and data and so on. What makes game programming different? So in game programming, the big difference, in my opinion, and maybe you ask somebody else, you get a different opinion, a different thing here. In game programming, it's about the interaction with the users. Interaction. It's at that scale where people feel engaged and pulled in and challenged and, committed in many ways to what's going on, right? It's a connection that you make. And it's about, as programmers, making sure that connection feels live and attentive and responsive and so on, right? Because it's with that human scale in mind. It's not just, okay, run an algorithm as fast as you can or as accurately as you can or just as easily as you can. At the end of the result, a minute later something, the result pops up on the screen telling you, yes, it's going to be cold and rainy on Tuesday, right? That's a different type of programming. Maybe running simulations and getting a result at the end is very different than being involved in a simulation that's part of the game, right? Often game simulation is more about the experience as opposed to the accuracy even, right? So game programming is for the experience of the user and the engagement with the user, and that happens at lots and lots of different levels, right? So we're always going to be concerned with efficiency and presentation and how things work, right? So it's not just write some cool code that runs and spits out the result when we're done. All right. Any questions? All right. I gotta watch the time since I'm trying to compress things down. So we're gonna be using Unity and C#. You're gonna be wanting to use the student version. If you go to Google Unity, I think it's unity3d.com. Go there, sign up for the student license. You'll be asked to establish an account. You can use, if you already have an account, feel free to use that one. You don't need to create a new account necessarily. It's not attached to your RPI account in any way, shape, or form, other than if you use your RPI email address to register for it. Okay. I don't even know if they require you to use an EDU address to qualify as a Unity student license. They used to have a program where you'd get some additional GitHub resources and things like that. Don't worry about that. We just want to get the engine installed on your computer. That's the main thing. So homework 0 for today is going to be install Unity on your computer. It's going to be Unity 2021, and it's going to include Visual Studio Community so that you can write code. And basically that's going to be it, right? The student license is great because it is a full license. It has all the features. You're not limited in any way, shape, or form other than you can't have a massive team of people that are all collaborating together with it, which you're not going to do anyway. Okay. In the ideal world, we would just install this Unity 2021 right now and keep that version throughout the semester. I encourage that, but chances are something may change. There may be a bug. You may think you have a bug. You might want to grab the newest version. Sometimes grabbing the new version is going to cause more problems than it fixes. These days, it's fairly easy to go back and forth between different versions. I may or may not, right now I have the most current version, but if you get an even newer version and I don't have that version, the problem is potentially that maybe Unity performs or acts differently on my computer than it does on yours, right? Usually that's not much of an issue. but that can be an issue. So that's one reason to kind of say, well, don't upgrade versions unless you have some compelling reason to. In the future, you're going to be working with teams, and there it's going to be extra important that you agree, okay, my team, we're all going to work with this version of Unity, and if someone wants to change versions, well, they've got to make a pitch to the team as to why they want to do that and move off from our current version to the next version, because especially with teams, you want to be on the same version so that there's no issues in performance or behavior between different versions of Unity, because it happens. Unity, C#. Sage advice starting out, and this one never works. It works great in person, but Jake the dog here is saying the first step at being good at something is to suck at it, right? So be prepared to write really shitty games out of the thing. And the first game we're going to write is barely even a game. It's more, sort of a, text box, back and forth, little narrative, little one-room adventure. Really, really simple thing. It's not something meant to be elaborate. It's really just kind of jump us in there and maybe even think a little bit differently about the game so that you can think about the core things that are happening as opposed to, worrying about juggling 10 things at once, right? So the first thing to do is to not be afraid to be bad at what we're going to do. So that's okay. The next thing I like to stress is in this class, the projects are largely about quality and not quantity of things. You have to manage your ambition. You have to avoid temptation to overcomplicate things, because very often you may fall in love with one particular thing or spend all your time on that one particular feature that in the end completely drowns your project and just causes the train wreck. Right, so you want to be very careful to balance things, to in your head have some sort of roadmap that you're working from to get you from here to where you are at the end, so that you don't wind up at the end being like, oh my god, I've got this one great feature and nothing else works. Or even worse, I was spending all my time on this one great feature that still doesn't work and I didn't leave any time to do anything else, right? So it's quality and evenness, not necessarily quantity and overwhelming. You don't have to dazzle me. I know you're all capable. You're going to be capable of doing amazing, dazzling things. But for now, we want to establish a good foundation, right, of different things and getting there, get good habits and so on. Right, avoid this temptation of thinking that, oh, this has to be a statement piece. I have to write some awesome game. Get that out of your head immediately. Right. This program is not about writing the most awesome game. It's about establishing good practices, behaviors, and foundations to things. All right. Time management, super, super, super important, as you've probably discovered by now, not just in this course, but in any course here at RPI. Try your best, don't fall behind. I like to, do things in such a way that they build, right? These projects, if you follow along and you do what's going on in the lecture and you actually implement, you try the things out as we're doing them in class, you'll find that quite often, just by following along, you'll wind up with the project done, right? Because we want to take this one bite at a time approach, as opposed to saying, well, okay, just avoid, and then the last minute, spend that one weekend trying to implement the whole project. Can you do that? Can it be done? Yes, it can be. If you experience with Unity, sure. The length of or the depth of these projects aren't meant to be super, super stressful. So, if you've been programming with Unity for a few years already and you just want to say, all right, I'm just going to see what happens by, trying to do it all in one weekend right before it's due. Yeah, it can happen. I don't recommend it. I've usually seen that backfire on people. But eat the elephant one bite at a time. Best way to do it. Also, there's no shame flute. I spend way too much time on this slide most of the time. It's a medieval torture device. Basically, if you were a bad musician or you created you had a crime against music, they would pillory you in this special way where they would force you to be have this thing attached around your neck and imitating the stance you would take if you were playing music, just to put you on public display and shame you for the bad music you played. There is no version of this in this class. There are no dumb questions, especially if you ask a question early on. It takes on, typically takes on, plus 10 brilliance by the earlier you ask it, right? So, because, for a lot of you, this will be your first experience in game programming and Unity and so on. So if you've never encountered something before, hey, What does this button do? I don't understand. I just clicked there. That button didn't do the right thing. Why would you know what it did? It's your first time. Go ahead. Feel free to ask the question. Ask it early on. What I hate seeing happen is that it gets to the final deadline and suddenly, you ask, hey, what does this button do when I've showed it to you or have demonstrated it or we've done it and we've presented you with opportunities to it for the past 2 weeks, right? Then things feel like, why weren't you paying attention, right? That's when the later these things go, the later the simple issues go, that's when they start to feel, oh, ouch, So get the simple questions early on, and they're no bad early questions. Right. Okay. Be prepared to enjoy the challenge. If you're a Sisyphus, cursed by the gods for stealing fire, that you have to roll this boulder up and down the mountain, or up the mountain every day, and it falls back down every night. You have to roll it up the mountain every day again for all of eternity. Maybe it's time to say, well, look for something enjoyable at it, because you're going to be doing it, right? It's a secret to programming, I find, is enjoying the challenge. Enjoy programming. Enjoy finding bugs. A bug, when you're presented with a bug, is like, great. There's room for improvement. There's something I can fix. There's some, so try to be positive. Try to enjoy the challenge of programming for what it is. Imagine Sisyphus if you said, okay, I like working out. I'm going to push some serious weight here, lift tons and tons of weight every day and you work out. Taking the right attitude, then a curse isn't a curse anymore. It's just something you enjoy doing. I don't know, maybe not. Okay. Occasionally working with third-party stuff above and beyond the thing that you install soon, the basic version of Unity. Occasionally, I will provide things in class, packages that are pre-packaged, your lobby scene and so on. But other than that, your code should all be original. You shouldn't be using things unless we agree up front. Things like, I forget if someone from this section or the last section asked about the A-star path planning algorithm and AI agents and things like that. We don't want to use any pre-packaged assets that come from the Unity Asset Store or any optional components that provide additional functionality, because in many ways we want to again focus on the foundations. Sometimes we're going to be inventing our own, and it's not going to be fair to say, oh, okay, I used all these collision whatever stuff when we were trying to say, okay, let's implement a sphere collider from scratch. So be careful about how to do that. You'll probably see other things. You'll see other YouTube tutorials. You'll see other Unity Learn things that you're going to want to potentially incorporate, and that's okay. But make sure, like I said here, if you use code from class or other sources, I expect you to add comments in your own voice to show that you understand it. I expect you to be prepared to talk about it. So if I see some really complex thing that is well above and beyond what I would expect to see in somebody's project, I'll ask you about it. And if you can explain it and how you got to that solution and what interested you about it, how you implemented it, great. If you say, well, I got to be honest, I cut and paste it, not great. Okay. So generally, no third-party scripts, libraries, packages, components, etc. are allowed unless there's some specific purpose to it and you're extending it in some fantastic way because you're more kind of advanced on things. Now, that's with the exception of art in games, right? This isn't the art course, this isn't pixel art, this isn't 3D art, this isn't animation and so on. So we're okay. I'm okay with you using other art assets, whether they come from the Unity Asset Store or other sources, online, just Google image searches, or even audio, sound, and music. I try to recommend you use royalty-free music and not full MP3s of your favorite songs, because usually that's unnecessary, and there's lots of royalty-free music out there. And often it looks cooler if you do want to show somebody else your game, that you're not just you're going to run into issues with royalty-bound music. I'm not going to judge you on your art skills. I'm not going to give bonus points for really cool art. So really cool art is generally not going to get you out of a jam when it comes to programming, because this is the programming side. So be careful about that. I've seen some people who did amazing work and spent lots of time on it. And in the end, I feel terrible because clearly they spent all their time, lots of extra time on doing art. And that's not the purpose. And, that's time they should have spent on something else. But anyway, we're the programming class. Be careful when you do get assets from maybe the asset store. You're trying to find just a sprite, set of sprites or a set of backgrounds and all that. Don't use the built-in scripts that often come with them. Don't use the built-in scenes that come with them. Don't use the built-in prefabs that come with them. These terms will make sense soon, but you just want to use the art, the raw art itself, right? The 3D model or the animation, the 2D pixel art or the animation, the audio, but not prefabs and scripts that might come along with game assets. Right? So be careful of that, because this is intro to game programming. The programming is the part that I'm going to be trying to judge you all on and get you going with. Right? Now, programming isn't necessarily just typing anymore. It's not just text-based anymore. And Unity now has this built in with 2021. It is no longer Bolt. It is actually Unity Visual Scripting. And it is built in right from the get-go. So this is why I want to make sure that your projects are Unity 2021, because we will do some stuff. We will do some stuff in visual scripting. Why? You may hate it, you may like it, you may love it, but one of the cool things about doing it here is that it also provides you a general introduction, a soft introduction to visual scripting. And when you get to something like Unreal and you're doing blueprints, some of what you learn here will help you to make that leap over to blueprints as well, right? So it's not just unique, a phenomenon that's unique to Unity, right? It's free, it's built in, and thankfully now it's an option for us. And more or less anything you can do in code, in traditional text code, you can more or less do in Unity. And there's some things that become easier to do. We'll talk about them and the strengths and weaknesses of different approaches. All right. Now, 311. All right. Important stuff. Okay, in this class, what's the work going to be? I've referred to these projects before, and it's going to be, in the end, it's a 4-in-1 project. There's going to be one project that has 4 levels. You're going to have a lobby that has 4 buttons, and each one of those buttons will lead to a level that is one of these 4 games, right? These games typically are, different parts of different genres that sort of build upon one another, build, on your knowledge of the engine, about the type of things you're going to include, the type you're going to be able to implement. I put these little explosion things in here to stress that this slide here is a great resource. Even further down the line, you may want to come back to this original slide deck and say, okay, what was it I'm supposed to do? When was I supposed to be actually doing that stuff? What project should that have been in? It's a great roadmap for your feature points here, right? So the first project is this simple text audio adventure. There's going to be a bunch of slides that follow from here that talk about that, what that's going to be. It's really meant to get you into C# and Bolt, learn the Unity editor, learn Visual Studio Community, some debugging concepts, the Unity canvas and UI system, basic Unity objects and components, basic concepts in interactivity, and we're going to do some brute force programming. We're going to do some things in this project that normally you would let the engine do for you. We're going to basically implement our own sort of circle collision or kind of overlapping circles to figure out, okay, is this thing on top of that thing? Did these things encounter one another? How do we do those sorts of things, right? So the simple text audio adventure, there's going to be very, very little graphics, if any, to that. It's mostly going to be heads-up display, Unity canvas, buttons, sliders, text boxes. That's the idea behind this one. There shouldn't be any sprites necessary. If there is a sprite, it should be strictly for adornment, and we can turn it off and the game still plays fine without it, right? I'll show you a cheat way to kind of, get 2 for the price of 1 in there. But the idea of the game is that it's going to be largely narrative-based. You're going to be telling a story and interacting with the user through the UI, providing feedback in terms of text and audio, right? So I like to put the audio up front because too often in game programming, audio is an afterthought, and I like to put it up front because I consider it to be an important part of any game, right? Unless you specifically have some reason for not having audio in there, right? Think of it as escape the room. The basic idea is, I always have this one, okay, you wake up in a dark room, you have to figure out your way around, right? Maybe you feel around, maybe you hear a ticking sound, or maybe you feel a warmth, or, the classic is you move and the game tells you, you feel warmer or colder, right? We'll talk about how to figure out, distance between objects and orientation and where they are in the room and so on. And so we get a feel for how objects and how 3D math or 2D math, vector math, matrix math, how all that sort of works in this first game. So it's important you kind of follow the spirit of it, because we're going to look at some fundamental concepts in there. The second project is Apple Picker, Kaboom, classic arcade action. There's going to be an antagonist that runs back and forth on the top of the screen, dropping items that you have to catch. Right, so we'll be using mouse input there. We're going to have a real game world. Usually we do these things in 2D. Usually we do all 4 projects in 2D. Going to open that up a little bit. If any of you do have 3D experience, or maybe we'll provide some alternative ways of doing some things. But the idea, and here is, like I said, it's arcade action, and there we're going to start introducing other things like C# collections, lists, arrays, dictionaries. We're going to be using more built-in engine features like start, update, on collision, and so on, introducing Unity prefabs and user input like the mouse. Scripted behaviors. So here we're going to be having objects that have their own behaviors and antagonists, enemies, and so on. Real-time decision-making logic, a little bit of statistics, and a little bit of randomness, and so on. Basic colliders, and even some rigid body physics. Right, moving way through there. The second 2 projects, things open up a lot. The first one is supposed to be sort of a shoot 'em up bullet hell RPG. Could be Asteroids, could be Tohu, could be Enter the Gungeon, could be an RPG, Pokemon. Classic example of that sort of top-down. This is a top-down shoot 'em up sort of game. And the final project usually is a platform, side-scrolling, lots of room for interpretation, lots of physics, lots of environmental aspects in that game. Okay, so we're going to build from there. Ideally, everything is submitted as one Unity project, like I said, with 4 levels in it, and you're going to work through each one. It also helps to learn about managing the differences and managing different scenes and how we can work between one and the other and have support different features and capabilities in our games. All right, so those are where we're gonna go. This is this one project to rule them all. We're gonna have a simple lobby, and this way we don't have to manage 150 different games from everybody. We only have to manage 49 different games from all the students this semester, as opposed to 200 games. So it's a managerial administrative nightmare for me, right? So some more information about them, right? This is really just so you have, if you ever are wondering about any of the projects, you can always refer back to day 1 and say, well, what was the intent? What was the grassroots growing point for these projects, right? Here's where we are. Now, talk a little bit of the grading system. If we can get through this, we're in good shape. The grading system is important. So started this in 2021, summer. It's worked out pretty well, and it makes it that much easier for you to say, okay, I want to get an A. How do I get there, right? I'm okay getting a B. Am I getting a B right now? And so on. So submitting each project on time and complete, just from the project perspective, is worth 40% of your grade. Each project was worth 10 points, 10%. Some portion of that will be a design document. Usually that's 3 points. So 3 points for the design document, 7 points for a workable, usable, reasonable game. And that's 7 points, overall 10 points, can be viewed as somewhat subjective from my perspective, right? I have the thing saying, okay, you totally missed the point. You didn't get the assignment. It doesn't play like a game. It's not complete. It's just, right? That's that portion. But 40% or 10% for each game, that's not an awful lot. So we can, have some stuff that's fairly kind of cut and dried, or, more attainable or quantifiable. So this other 60% comes from our feature points, right? Our experience points feature. Imagine we're starting from 0. We have certain level milestones we're going to get 10% bumps on. But then along the way, you are free to implement any features, and I'm going to talk about them in class. We're going to be going over them as topics. You implement features using the techniques in class, and you will earn feature points as pointed out in the syllabus, in that list at the very end of the syllabus, about, for implementing a certain feature, you get a certain number of points. Some features can be implemented multiple times across multiple projects. Sometimes you can even get multiple points for them within the same project, depending on how different, right? If you've implemented shooting in 2 different ways, maybe you get 1.5 times the normal shooting bonus, or maybe you get 2 times, depending on how elaborate it is. In order to get the points for that, it's important that you comment your code, right? So this is where we're going to like really stress commenting the code. You will put a comment that says / feature point and then a brief explanation of the comment, at least being the name of the feature that you are implementing, right? And be prepared to say, well, I've seen some people say, oh, you used inheritance here, and they didn't use inheritance, and they had to, kind of defend why they thought that was inheritance or something like that, right? But you're going to need to put that in there. Why is that so important? Well, when it comes to grading, what we typically do is do a search all inside of Visual Studio, and we search for feature. And Visual Studio will give us a nice list of everywhere it encounters the term feature. And then we'll be able to look, because you will be creating lots of scripts and things will be all over the place, and it'll be really tough to say, okay, where did you actually implement linked lists, or where did you implement arrays, or where did you implement colliders or circle casting and so on. So it's very, very, very important that you comment your code, get in a good habit of it right away, and put in your feature point comments so that we can see what you did, right? And the rest is if your implementations are particularly good, maybe we'll multiply the bonus, multiply the modifiers for the feature points, and if you revisit a feature and show some additional progress along there, maybe you can get counted more than once. If you want, you can go to https://erasermice.itch.io, prototype full physics platformer, and you can see a version of some games. Usually every semester I will kind of rewrite these in some different genre, or subject to some new interesting decision on my part. But you can get a feel for some of the general guidelines and what approaches I've taken to the game. So by visiting my itch channel. Homework 0, get Unity installed. Install Visual Studio, probably Visual Studio Community with it. Community or code, doesn't have to be a professional license or anything like that. It's really going to be just using the editor and the debugger, but that's important. So install it as part of install Visual Studio as part of Unity. That's the safest thing to do. Use Unity 2021. Go the normal route. There's other ways to install new versions. We won't worry about them too much. Just go through the normal process at the Unity site. You'll sign up, you'll get a license, it'll email you, have a license number maybe, and you'll add that, plug that in when it asks you to. So there'll be a little bit back and forth, just like registering any piece of software. When you create a project, for now you can create any project you like and kind of dabble and see what's going on, but ultimately you're going to be creating a 2D universal render pipeline, URP project, and you're going to name it with your RCS ID, which is your email. If I like it, Amory_GSAS 2540, so that I know the name and so on, so I can find it. That used to be more important. If we wind up using Perforce as our version management system, it'll be less important, but we're still fighting for licenses on that. We'll resolve that hopefully this week. You may also need to create an organization. I recommend just, again, your RCS ID _org. If Unity asks you to create an organization, just go ahead and do that. Totally fine. All right. Again, Visual Studio Community is good enough. You want to install WebGL build support, because that's what you're going to use to build web versions of your game, so that you can submit to the web, and then this way you have a checkpoint to say, okay, yeah, I built a version of the game that actually ran and worked, and it was on the web, and a friend of mine visited that website and checked it. So therefore, you know that when I go to look for it, it'll work. As opposed to if you submit something in Perforce and some glitch happens along the way, or you forgot to submit your code, or at the last minute you did this, that, or the other thing, there's always that chance of something falling between the cracks. But having a web version submitted or a web version published, it's a good practice to get into, and it also proves that, yeah, it was working when you submitted it. All right, so that's why when you install, you should also install WebGL support. Optionally, you can put Windows build support or Mac build support if you want. You build standalone applications. Right? That's why we do that. So in interest of kind of wrapping things up, this is a bit redundant here. So what are we going to recover? What are we going to cover? Design to implementation. We're going to start, plan your games, build your games, solidify your ideas. We're going to cover a lot of the architecture and engine basics, what's going on under the covers. We're going to cover programming and scripting, both from a language and conceptual point. We're going to talk about things important to games like math, timing, physics, user interaction, and so on. Managing assets and how to implement them and integrate them into your games. How do we get the graphics in and animation and audio? Some basic AI and simulation techniques. We're going to do things like character control, animation, and automation for the player. You also have things like animated cameras or moving cameras, debugging techniques, programming practices, collaborating, and so on and so on. All right, so think now about, you'll notice in the syllabus, the first thing that's going to be due is this back of the envelope thumbnail idea for an adventure. Think simple. Think, okay, I wake in a room, I want to get out of the room, or I want to accomplish something. Some people, there's been like cooking simulator versions of this. There have been people finding their lost dog. There have been people, it's really, really great. Use your imagination on here. Think narratively. Think of telling a story with words and sound, but make it, one room, simple adventure. And the next couple of slides, I want you to refer to as the basic requirements for it, right? Inputs are going to be largely text or UI based, right? You don't want, not key presses, but actually using buttons, using sliders. You're going to create a directional pad using buttons that we connect to events in Unity. It's not going to be hit A at WASD. It's going to be click a button on the screen with various user interface elements. And think about, all right, how do you get the story across to the user? Without showing them on the screen where they are in the room, how do you tell them, are they getting closer to the goal, right? Some examples are, create sound that gets louder and softer, or tell them you feel warmer, you feel colder, you smell something, and so on, right? So think about that. How do you, call and respond, and so on, right? We're going to look at some math in terms of that, figuring out proximity and start thinking in object-oriented ways. And we're going to be doing stuff, from the ground up. We don't want there to be maps in our games, right? It's not going to be a grid of things. And some of you might have already written games where you created a set of cells on your screen, a 4x4 array, and there's an object in each one of those cells. That's not this game. This game is going to be, there's going to be objects, and they're going to have locations of their own, right? So that world could be infinitely large or very small with lots of accuracy and have lots of things in there, and there could be things that are on the same location. It should not be a grid-based game. Things should we should be dealing with entities that know where they are in the world and potentially how they're going to interact with one another. So that's going to be there. I'll let you read through some of these things. These are kind of my guidelines for approaching the game. And I'm going to wrap it up there. We don't really have time to try stuff just yet, but the important part is going to be installing Unity 2021, installing Visual Studio. If you can open a game, if you can create a game and open it, we're in great shape. If you run into any issues on there, please reach out on Discord. Rebecca and I will be watching, and soon Justin will be watching as well, kind of help you through the whole install process. But we want you to have Unity running on your computer, on your laptop, in class, prepared, so that you can actually try out things as we go through them in class, and do kind of impromptu exercises that we go through as part of some of the lectures. So be prepared to have that start to happen in the next class. Okay. Any questions? If there are, or if they're just one-off questions, please do put them in Discord. Ask them through that. Direct mail me, direct message me, reach out whatever way you are comfortable with. And I look forward to a great semester. Look forward to having a lot of fun. These are big classes. Look forward to seeing everyone in person. Relatively large. I guess we're at 20, like I said, 25 people or so. It should be a lot of fun. Okay, everybody? All right. On that note, have a great rest of your, have a great rest of your Tuesday. Have a great Wednesday, and we'll see you on Friday. Well, have a great Thursday, too. We'll see you on Friday.